Now welcome to Sri Ganit Vijnana Sarvasvam JEE and Eamcet online video channel. This video is presented by B. Ramesh Kumar, JL in Mathematics. Today our topic is circles in senior intermediate. Here I am showing weightage of marks in various examinations. That is IPE, Intermediate Public Examination, IIT JEE Mains, Eamcet and JEE Advanced. Now the next column will be showed various questions and weightage of marks. Now I will continue the concept of circles part 2. Here in this video I explain intercepts, concentric circles, diameter form, angle in semicircle, notations, definitions of chord, secant line and tangent line, power and position of a point of the given circle, and maximum and minimum distance from a point to circle, parametric forms and concyclic points. So listen carefully. Now we go to length of the intercepts of the circle on coordinate axis. First we observe the diagram. Here we see that the circle cuts off intercepts on x-axis at 2 points A and B. Now these points lie on the x-axis. Then we observe that coordinates of A and B are zeros. Now the value y equals 0 put in given equation of circle, then the circle will be converted into x square plus 2gx plus c equals to 0. Now which is quadratic equation in x. Let the roots be x1 and x2. Then we take sum of the roots x1 plus x2 equals to, from this equation the value will be minus 2g, and product of the roots equals to, that value will be equals to c. Now using these two conditions, then find the value of absolute value of x1 minus x2, that equals to 2 into square root of g square minus c. Here we observe that the value of x1 minus x2, modulus x1 minus x2 or modulus x2 minus x1, is the length of the intercepts AB. Length of the intercepts AB. Now if g square minus c is greater than 0, the length of the intercepts made by the circle s equals 0 on x-axis is AB equals to 2 root square root g square minus c. That is length of the AB. Similarly, next observe the diagram. Here also the circle cuts y-axis at 2 points A and B. Here these 2 points lie on y-axis, then the x-coordinates are zeros. In the same way, we put x equals 0 in the given equation of circle, then the equation will be y square plus 2fy plus c equals to 0, which is also quadratic equation in y. Now the roots will be y1 and y2. Using the sum of the roots condition, y1 plus y2 equals to minus 2f and y1 y2 equals c. These are sum of the roots and product of the roots. Now using the results, then we get the value of absolute value of y1 minus y2, that will be 2 into square root of f square minus c. Here f square minus c is positive, then the length of the intercepts made by the circle s equals 0 on y axis is ab equals to 2 into square root of f square minus c. This is the length of the intercepts on y axis. Now these two are length of the intercepts. Now we go to concentric circles. First we observe the diagram. This is the first circle. This is another circle. Now we observe that these two circles having same center. Now we observe that these two circles having same center, and also but different radius are there. These two circles have different radius. Now in equation manner, the equation of circle is x square plus y square plus 2gx plus 2fy plus c equals 0, which is of the form of x square plus y square plus 2gx plus 2fy plus k equals to 0. Here we observe the constants c and k are different, and the coefficients of x and y are same. Now the centers of these two circles are equal, but radius are different. Now we see these two equations. The circles concentric or not, now basically dependent by constants only. Now this type of circles are concentric circles. Next, diameter form of the circle. Now we take one circle, and this is the center, and these points are end points of the diameter. Let it be a x1 y1 and b x2 y2. Now we take p of xy be any point on the circle and join pa and pb. We observe the angle of APB is equals to half of the angle of ACB. In geometrical theory, the angle of APB is half of angle of ACB. Here we know that angle ACB equals to 180 degrees. Therefore, angle APB is 90 degrees, because of this is half of angle ACB. And we observe PA and PB is always perpendicular to each other. Therefore, the slopes of these lines, the product of the slopes of these lines equals to -1. Now we can find slopes using the slope formula, that is y minus y1 by x minus x1, which is the slope of PA, and y minus y2 by x minus x2, which is the slope of PB. Therefore, y minus y1 into y minus y2 equals to x minus x1 into x minus x2. Now, the equation of the circle is x minus x1 into x minus x2 plus y minus y1 into y minus y2 equals to 0. Now, it can simplify. The circle equation is x square plus y square minus x1 plus x2 into x minus y1 plus y2 into y plus x1 x2 plus y1 y2 equals to 0. Now, this is the diameter form of the circle. Here we go to notations of different curves, that is circles, conic sections, and etc. First we observe the circle equation is x square plus y square plus 2jx plus 2fy plus c equals to 0. Here it can be written as s equals to x square will be x into x and y square replaced by y into y plus g into x plus x, and here also f into y plus y plus c equals to 0. So in this second terms x y, will be replaced by some x1, that is denoted by S1, that is denoted by S1. Therefore, S1 equals to xx1 plus yy1 plus g into x plus x1 plus f into y plus y1 plus c. Similarly, S12, here first term x, first term y will be replaced by x1 and y1, and second term x and y replaced by x2 and y2. Therefore, it will be also written as S12. This is denoted by S12. So, therefore, S12 equals to x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c. Constant do not change. Constant b do not change. G and F also do not change. And similarly, S11. S11 means both x and x, y and y are replaced by x1 and y1. Therefore, this is denoted by S11. That is, S11 equals to x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Similarly, S22 also x2 into y2, x2 into x2 square plus y2 square plus 2gx2 plus 2fy2 plus c. Similarly, here first x and second x, first y and second y both are changed by different scripts. Here generally, here I take first script is 1, second script is 2, first script is 1 and 1, 2 and 2. So, already written as 3 and 3, 4 and 4, j and j, some n and n, k and l. So, we take any numbers in these notations is as follows in the same manner. Therefore, this is the different notations now using our concept of circles as well as our concept of conics and remaining curves chapters. So, already we know these results. This is the different notations for in this concept. Now we go to definition of chord, secant line and tangent line. Here observe the diagram. This is one of the circle and AB is line segment. We observe the endpoints of AB completely lie on the circle. Now this type of line segment is called chord of the circle, and we observe that the length AB, the length of AB is called length of the chord. So here the length of the chord, it may be some finite length. So it is the maximum length if it passes through the center. It passes through the center. Then that type of chord is called diameter of the circle also. The type of chord is called diameter. So which is passing through the center. And we observe, now we observe remaining two diagrams. Here A and B are 2 points lie on the circle, and one line is passing through 2 points A and B to the circle. And here also the line passing through 1 point to the circle at the point A. So we observe these two diagrams. Any line passing through 2 points to the circle, that line is called secant line, and any line passing through 1 point to the circle, that line is called tangent line. Here the limiting point of secant line, the limiting point means the length of AB is minimizing in this diagram. that equals to 0. So the points A and B are coincide each other. So it denotes one point. Here this line touches the circle. This line touches the circle. Now this type of line is called tangent line. So the limiting point of secant line is called tangent line, and here length of AB equals to 0, and the tangent line touches the circle at one and only one point. Here that point is called point of contact. That point is called point of contact. So in previous slide we observe the line segment AB is called chord of the circle. Here any line passing through 2 points, the type of line is called secant line. In the third diagram, the line passing through 1 point, now that type of line is called tangent line. So these are the definitions of chord, secant line and tangent line. Now we go to power of a point with respect to the circle s equal 0. Suppose we take one circle and the C is the center of the circle and P is one point, any point on the plane, and observe the diagram. In this also second circle we observe here P is lie inside the circle, and similarly another diagram we observe here P is lie outside the circle. So these are, in these P is lie outside, lie inside, lie on the circle. Now suppose S equal 0 be the any circle and P be any point x1 y1, P x1 y1 be any point, and C is the center, R is the radius, then the power of a point P with respect to the circle S equal to 0 is defined as Cp square minus R square. That is the difference between squares of Cp and radius. So here also observe that the point P lie inside the circle or on the circle or outside the circle according as power of P with respect to S equal 0. Now here power of a point with respect to S equal 0 is S11. This is one real number. This is one real number. So this real number is negative or 0 or positive. So here Cp square minus R square is called the power of the point with respect to the circle S equal to 0. Here one more result in the power of a point. First we observe the diagram. In this is one of the circle and PB any point on the plane, and these lines are passing through the same point P and meets the circle at two different points. Now the different points are A and B. Let it be A and B, and we observe the result is, let S equal 0 be any circle, P of x1 y1 be any point on the plane. Here C is the center and R is the radius. Already we know the power of point with P with respect to the circle S equal 0 is defined as S11. Already discussed in previous slide. So here we observe an infinite different lines. So many lines are passing through the one point, same point P, and meets the circle at 2 points A and B. Now we calculate the distances PA and PB. Now we find the product PA and PB is the same as the power of P. Is the same as the power of P. Here different lines will be taken. Now we calculate each line
PA and PB, and second line also PA and PB, third line also PA and PB, and calculate PA and PA into PB and find power of the point with respect to the circle as equals 0. Now we observe that the results are same. So the proof of this result already in our academic textbooks. Here I tell briefly. First of all, we take one general form, s equals to x square plus y square plus 2jx plus 2fy plus c equals to 0. Now here the parametric points each of the form x equal to some x1 plus r cos theta and y equals to y1 plus r sin theta. Now with these points, these parametric points, substitute in the general form of the equation, that is x square plus y square plus 2x plus 2fy plus c equals 0. Now we get the result is in quadratic form. Then we observe that in the quadratic form, the product of the roots. Now the product of the roots will be, one root will be PA and second root will be PB. Now the product of PA PB is always equals to S11. So this is one more result in the power of a point.
Now we go to position of a point. First we observe three diagrams. In these three diagrams, P is external point in the first diagram. In the second one, P is internal point. In third diagram, P is lie on the circle. Now I am telling about the position of the point P. First of all, we find out the power of the point P with respect to the given circle. Now using the formula, power of the point P with respect to s equals 0 is S11. Here we observe that S11 is one of the real number. Suppose S11 is greater than 0, then the position of the point P is lie outside the circle. Here also the power of the point is always equals to Cp square minus r square. So Cp square minus r square, that equals to S11, which is positive. Then the point P lie outside the circle. Similarly, in the same manner, the power of the point P is negative, that is Cp square minus r square is less than 0, then P lie inside the circle. The position of P is lie inside the circle. Similarly, the power of the point P of x1 y1 with respect to s equal 0 is s11 is equal to 0. Then the position of P is lie on the circle. So these are positions of a point mainly based on the power of the point.
Now we go to maximum and minimum distance from a point to the circle. First of all, we observe the diagram. Here, this is one of the circle. C is the center, and A and B are any 2 points on the circle, and PB any point on the plane. Now I am telling about maximum distance from the point to the circle. Let us consider the equation of circle equals to s equals 0. And from the diagram, PB is denoted by maximum distance. First we calculate distance from center to the point P, that is denoted by Cp, and find out the radius of the circle. Here The maximum distance is denoted by PB, which is equals to sum of the distances CP and radius of the circle. That is called maximum distance from the point P. Similarly, the minimum distance is denoted by PA. Here also already calculated CP, that is center distance from center to the point P, and radius of the circle. So the minimum distance from point P is PA equals to absolute value of CP minus R. So the difference between CP and radius. This is called minimum distance from the point P. Now we go to parametric forms of the circle. First we observe the diagram. Here we take one xy plane and another one is, it is the circle, and C is the center of the circle, and we draw two perpendicular lines from the center, and also one perpendicular line draw on x-axis from the center C, and here PB any point on the circle. Now we join CP and we draw one normal line on the circle on the x-axis, that is M. Here the intersection points, let it be N, D, M. Now we know that the radius of the circle is R, and also here observe the diagram CPN. The angle PCN will be theta, and also the measurements of OM, that is X, and OP is Y, and OD equal to H, and CD equal to K. Now the parametric equations of given circle is x equal to h plus r cos theta, y equals to k plus r sin theta. Now I am telling about the proof of these parametric forms here. So now we observe the diagram. Triangle PCN is right angle triangle. Now using trigonometric ratios, that is cos theta. The rule of cos theta equals to adjacent side by hypotenuse. Therefore, Cn by Cp. Cn by Cp. Now, here we observe the diagram. Cn is always equals to dm. Cn is always equals to dm. Now, we substitute the value of Cn, that is dm by Cp. Here, dm means the difference between origin to m and the difference between origin to d. So, that is OM minus OD by Cp. Here OM means x and OD means h. X minus h by Cp means radius. So x minus h by r. Now we simplify cos theta equals to x minus h by r. Then we get the value x equals to some h plus r cos theta. Here h is the x coordinate of center and r is the radius and theta be the angle of PCN. Similarly, sin theta equals to, in this diagram sin theta equals to, using the trigonometric ratio, opposite side by hypotenuse. So that is Pn by Cp. Here also Pn will be converted into the difference between Pm minus Mn. Pm minus Mn. Here Pm also known, that is Y, and Mn is always equals to CD from this diagram, that is the K value. So here Pm minus CD means Y minus K by Cp means R, which is the radius. So now it also simplifies sin theta equals to Y minus K by R. Then we get the result is y equals to k plus r sin theta. Here k is second coordinate of the center, and r is the radius. Now here x equals h plus r cos theta and y equals k plus r sin theta are the parametric forms of the given equation of circle. Here the angle theta is always lies between 0 to 2 pi. The angle theta is always lies between 0 to 2 pi. And similarly, one more result. The coordinates of any point on the circle. The coordinates of any point on the circle x square plus y square equal to r square. Here this is also one of the circle, but here the center of the circle equals to origin. So here x1 h and k equals to zeros. Then we get the parametric form will be converted into r cos theta into r cos theta comma r sin theta. So this is the parametric form of for the circle is passing through the origin. Next, the equation of chord. Here from the diagram, the equation of the chord joining 2 points alpha and beta. Now we take alpha and beta are 2 points on the circle. Then joining alpha and beta, that is the chord. Here the equation of chord will be x plus b into cos of alpha plus beta by 2 plus y plus f into sin of alpha plus beta by 2 equals to r into cos of alpha minus beta by 2. This is equation of chord. Here alpha and beta are 2 points in the parametric form. So this is the equation of chord. So these are some more important points in the parametric forms. And one more result in parametric form is the length of the chord of AB joining A theta 1 and B theta 2. Here A theta 1, B theta 2 are 2 points on the circle and join A and B. Now we get the line segment is called chord. Now we find the length of the chord in the parametric form of the circle x square plus y square equals to r square, or x minus x1 whole square plus y minus y1 whole square equal to r square. Here the two circles, one circle is passing through the origin, or we take as does not passing through the origin. Now this is the form of the circle equation. Here the length of the chord AB is denoted by 2r into absolute value of sine of theta 1 minus theta 2 by 2. Sine of theta 1 minus theta 2 by 2. Here the parametric angle differ by. Here the parametric angle is theta. Now this is theta equals to difference between theta 1 and theta 2. So therefore theta equals theta 1 minus theta 2. Now here AB, the chord AB subtends an angle theta at the center of the circle. This is one more result in the parametric forms. Next one is concyclic points. Here we observe the diagram. Now the circle is passing through the point A, similarly passing through the point B, C and D. Any circle passing through the points more than 3 points, then that points are called concyclic points. Here the points are non-collinear points. So these points does not lie on same line. These points are does not lie in same line. Therefore, the circle is passing through more than 3 non-collinear points. Then the type of points are called concyclic points. Here minimum points are 4, maximum points are infinite. So this is one of the concept in the circles. So in this video, I told different concepts in the circle and some more results to be continued in the same chapter in the next video. So if you like this video, press like button and subscribe this channel. So thank you.